Welcome to our lesson on round trip problems. Round trip is a type of uniform motion problem. Let's go ahead and read the question. You drive to the store at a rate of 45 miles per hour and return home the same route at a rate of 54 miles per hour. If the trip home took 20 minutes less than the trip there, how far was the store from your home? Now, let's think about this problem for a little bit before we begin. We are starting at our house, going to the store, and then it says we are taking the same route home. Obviously, because on the way home we're driving faster, it's going to take us less time. So let's identify a couple of things that we know. This problem is asking me, the final question is asking me to determine how far the store is from my house. So I know that this type of final answer is going to be a distance. Now, because I see that this rate is labeled in miles per hour, I know that my final answer is going to be something miles. And now let's go ahead and think about what variable we would like to define. Now, I know that I need to eventually figure out the distance. So right now I'm thinking about the distance formula. Distance equals rate times time. I obviously have my rates 45 miles per hour and 54 miles per hour, but the thing I don't have is the time. So what I'm going to need to do is I'm going to need to define my variable as time. Now again, we like to use the more mysterious variable. I don't know anything about the ride there, the amount of time it took me to get there, but I do know a little bit about the way back. So the way back home is not really mysterious because I know it's going to be 20 minutes less than whatever the way there was. So I'm going to let t equal the time it takes to travel to the store. So t is going to be our amount of time on the way there. All right, so let's go ahead and look at a model. This is going to be a round trip type problem. This brown square is going to represent your house. This brown square is going to represent the store. So let's go ahead and look at our model. We drive from our house to the store, we go shopping, and then we come back home. And what you'll notice is that the distance there is the same exact length as the distance back. Now that's very important for us to recognize because if the distance there is the same as the distance back, we're going to be able to make an equation setting both of the distances equal to each other. So again, similar to the same direction problems that we did, we're going to be able to develop some expressions for the distances, and then we can set the distances equal to each other. And again, the reason I can set the distance equal to each other is because up here we see that the route there and the route back were the same, and same means equal. Because the rate is in hours and the time is given in minutes, I have to rewrite that 20 minutes. And we know that 20 out of 60 is 1/3, so instead of 20 minutes, I'm going to use the number 1/3 of an hour. All right, so the distance there is going to be 45 miles per hour times the time, because I know that distance equals rate times time. And because the time back is less, my distance on the way back is going to be 54 times the quantity, time minus 1/3. And again, it took me less time on the way back, so that's where I get my minus sign. And it was 20 minutes less, which is where I get my 1/3. Now I can set the expressions equal to each other. Now we talked about this before. The way there is equal to the way back. So that's why I get 45t equals 54 times the quantity t minus 1/3. From here we can distribute 54 and we get 54t minus 18. I would subtract 54t from both sides and I get negative 9t equals negative 18. I divide by negative 9 and I get t equals 2. Now again, sorry, I got ahead of myself. Now again, this is not our final answer. It's very rare that in a uniform motion problem that the variable you solve for will be the final answer. Our final question says, how far was the store from your house. So again, how far refers to a distance, so we're going to use our distance formula. Distance equals rate times time. And we're going to just substitute in for either the way there or the way back. Now, because the way back had a fraction in it, I decided to use the way there. So it would have been distance equals rate 45 times time, 2 hours, and I find that my distance was 90 miles. So I can write myself a little phrase or sentence. The store was 90 miles from your house. That is it for now. Good luck on solving the rest of round trip problems.